let's start. Again, Paul, I'm relying on you for timings because my timer has already started.
Okay.
So, Docker 102. So previously we looked at a bunch of basic concepts for Docker. And that hopefully has given you guys a grounding in how to actually spin up containers. You know roughly what a container and an image is. So you've got some of the terminology down. You have some notion of how you can punch a hole in these containers for networking, but we haven't really gone into any detail on that. And how to do a certain amount of building your own container. We're going to park building containers for now, because fundamentally they are basically just running a series of shell commands. So if you're kind of happy with running commands in a terminal, it should be fairly straightforward to do that in a Docker file for building whatever you want to build. This session, and I'm going to go a little slower because I do have a chest infection, so do excuse me if I cough or anything. Paul, don't worry, it's not contagious.
Fun.
So this session, we're going to go a little bit further into isolation, so more about the concepts of isolation and how to break isolation. We'll go a little further into networking concepts and how networking with Docker works. And then we'll talk about Docker Compose, which is the beginnings of how to deal with multiple containers rather than just the one. And then the bit that's probably going to be most interesting to this particular audience for files and disks and I/O. So how do you actually get data in and out of these things? And then I have a little bit on the end about where you can take this all further, because a lot of the resources online are absolutely excellent for Docker. It is probably one of the best projects for documentation that I work with day to day. And that includes my own projects, which are terrible. Then I've got a little bit at the end about SEC's intent with Docker and resources that may become available shortly to everybody at SEC. So let's start talking about isolation to begin with. More and more people coming in, good lord. We covered what Docker actually meant when it said loosely isolated in the previous session. So this idea that it's trying to cut you off from the host system, but it does the bare minimum to do so. And we demonstrated how to poke holes in that with networking particularly. There are at least 3 ways to poke holes in containers in reality. There are actually quite a few of them. And we are going to look at the top 2 here. We're going to be looking at networking and storage. Devices, of which Stephen will tell you infinite stories of how difficult that may be. We can cover in the third part for those who are more interested in actually doing this with things like GPUs, ASICs, custom network cards, that kind of thing. But in the most cases, you'll be dealing with just networking and storage on a normal-ish host, or certainly a host which pretends to be normal, but that's by the by. So let's start with networking. There are several ways to configure your networking within a container. You could have none. You can literally remove the network interface entirely. So if you want to have a container that is totally isolated for whatever reason, if you're doing something that should never connect to the internet, then you can actually do -- networking equals none, and it won't even have a NIC available, a network interface card within the container. Nothing can connect out, nothing can connect in. The downside of that is, of course, you can't update anything in there, and you're then limited to other means of getting data in and out, whether that's writing code in interactive mode or whether it's mounting file systems, which we'll cover later. But you cannot do anything over the network at all. The next one is the polar opposite of this, host mode. Where host mode, you pretend to be the host. This will be familiar to folks who've messed around with things like VirtualBox in particular, whereby you can have a virtual machine in VirtualBox, as in Docker, that effectively pretends to be the host, and it has exactly the same networking rules as the host. So it will show up with the same IP, plus or minus a bit, or there's translation going on, but it looks like it's the same IP from both sides. It can open and close ports completely freely. It has full access for all protocols. It's only under the whim of the firewall for the host at that point. So Docker is basically doing nothing. It's just passing all the data through. And then finally, there are these 2, bridge and overlay mode. These honestly are the most interesting ones, and both do roughly the same thing, but they do it at different scales. We're going to primarily focus on bridge mode, so this is for a single host, as opposed to overlay mode, which is more like the thing you would see with container orchestrators, like if you were deploying to a large multi-host system. Bridge mode. Bridge mode is, like as I said, the single host default. It's actually the normal one you'll get if you just bring up a container with run-it or run. You'll get a bridge mode connection to the host. It does network address translation, that's NAT. So that allows the processes inside the container to connect to the outside world. This is why we could do things like apt-get update from within our container without having to configure the network. It does not, by default, allow things to go the other way. So it's like you being on your home network, where you can connect out to the wider internet, but the wider internet, in general, can't come back in. You can port forward, which is effectively what we did in the previous session when we used -p to poke a hole in our container. And we can do this either based on a port number rule, or you can also do it on protocol-based rules. So you can say you only want TCP or you only want UDP. And yeah, this is very similar to what you would see on a regular router. You know, you open the port to the world, it sends it through to something in a container, job's good. Overlay mode is very similar, but for more than one host. The really neat thing with overlay mode is that if you run using some form of orchestrator, whether that's Swarm, whether it's Compose, whether it's Nomad, whether it's any of the other ones, and they launch multiple instances of containers, and they span separate hosts, the network, for the purposes of the containers, looks like a flat LAN. They can all just talk to each other as if they were in bridge mode. So they can see each other and communicate as per the previous one, except they exist in different places. Normally, unless you're running a smaller cluster, you'll not see this mode, however. This is the default in Swarm mode, because most of the larger container systems have their own overlay networks that are not Docker's internal overlay network. They implement their own to deal with their networks. But most big systems, like using any container orchestrator, will do something similar to let you link your containers up. But a little routing aside, whatever you're doing with any of this, this pattern is incredibly common. You'll see it everywhere. And it's most common when you have web applications, where you want to have one to many local containers, all thinking they're the only thing connecting out to clients for web purposes. So these are the serving web pages or serving web sockets or whatever else they're doing. They want to think they're the only one. The problem is you can't do that on a single host on the same port for all of them. They will all try and use the same port. The host will go, no, you can't do that. The solution to this is a reverse proxy, and Nginx is certainly the one I use most often. There are others. There are various load balancing type ones, for instance. But Nginx is a nice one to set up. And it will take our 80 TCP connection. I'm ignoring SSL for the time being. That's a whole other kettle of haddock. And it takes that connection from our web browser and translates it into our connection to a container. And it knows internally in its configuration that if you go to a certain address or a certain path, you will get a certain container address. So you end up with setups like this, where you have several containers running behind a single balancing process, in this case Nginx, that then presents this as a single endpoint to all the users. Interestingly, apart from the web browser, all of that on the right, so Nginx and the applications, can all be containers. They can, the actual web load balancer and reverse proxy can be within a container itself, in host mode probably, or with 80 and 443 ports open. If you're doing anything within the university for smaller website development, this is probably what we're going to move towards. So rather than you being given a new VM for every small website that then has to be maintained and updated, we'll be moving more towards a containerized system. So you can expect to see more of this if you're, certainly with Lancaster, I would expect kind of universally you'll see this more and more as the general model for small setups. But previously, you remember that we used -p, where we just used two ports. We said we wanted the external port and the internal port to be whatever they are. In our previous example, it was like 8080 and 80. But doing that actually opens it to everything. That makes it listen on the global interface. That's 0.0.0.0, the any interface. And would, in theory, allow, in this example, somebody to connect from the web browser directly to the box that the Nginx and containers are running on with port 8101 and go straight through to the container, which is not necessarily what you want. You want it to be restricted to within a single host. So it can be quite important to include that first bit here, the loopback at the bottom address, which is 127.0.0.1, which then binds only to that host. So now only connections from the host, in this case with Nginx running on it, can connect through, because the only thing that should need to connect through is Nginx. So we're fine. As good practice, it's worth having that there unless you have a reason not to, because it's probably what you want. If you're not doing that, you've got to think, why am I not doing that? And understand the ramifications of doing that, because then you're opening yourself up to the wider world. But all of this we've seen so far is for accessing containers externally, but we want to be able to talk between containers. So we're going to do a little bit of a play along like we did before. This time we're going to be spinning up MariaDB and phpMyAdmin, and we're going to run them together. We need to launch 2 containers to achieve this, and we could launch them both separately. You know, we could do 2 Docker runs, 2 different terminals. We could run them in the background if we wanted to, but we're lazy, and there are way better ways. And if there's not a reason not to use Docker Compose, we should be using Docker Compose. So, Docker Compose. What is it and how is it done? They have the best logo. I love that it's essentially a Kraken, especially bearing in mind that the Docker logo was that whale with all containers at the top, and Docker Compose appears to have nicked them all. Just seem a little bit mean. But Docker Compose is essentially a tool to describe the arrangement of containers and pass along the configurations to them in an easily repeatable way. And all the configuration is based around YAML files. Most of the time you'll simply see one, and it's going to be called docker_compose.yml. You probably want to open this in your favorite text editor at this point, in a new folder somewhere on your system. And we're going to be looking at a simple completed Docker Compose YML in a moment, and step through each set of lines and talk about what each thing is doing. So here's the beginnings of a Docker Compose file. It's YAML, so we're talking about space indentation, and the scopes are Python style. So within an indentation level, it's talking to the parent is one indentation level higher up. So at the top level, we always have a version, so we can tell Docker Compose which version we're using. This one we're going to use 3.1, which is nearly the latest, but not quite. And you almost always have at least a services block at the root level. There are other things in there. There are volumes, for instance, which is very common. But you're almost always going to have a services thing. You're unlikely to want to use Docker Compose without any parts of Docker in it. That's a bit strange. And the services one lists the containers that we're going to run. The DB block here, and I've named it particularly awkwardly here. I actually renamed this to database later in this deck. But DB here is the name of the container at runtime for the purposes of this Compose instance. You'll see how that works in a moment. And it actually becomes a network name within the bridge network that we'll be creating. So we'll be able to refer to this container instance as just DB, and we'll know where to find it, provided we're also inside this container. Don't worry if I'm adding more and more to this file as we go along. The file will build on screen. I'm not going to hide any previous parts of this, except for very small changes, so you'll be able to sort of catch up as we're going along. There shouldn't be any super surprises here. There's, an image, because it's a container. We have to tell it what image we're using. This time we're using MariaDB, and it's version 10.6. We're doing this through the tag mechanism, remembering that anything after the colon is a tag to specify a particular version. I've thrown in a restart policy here, so a restart there forces it to restart every time. So whether it's a crash, whether it's a normal stop and start, anything else, just always restart this container. We're going to need it. There are a few others. Another good one there is unless_stopped. So if you explicitly say stop that service, it will then not bother bringing it back up again. Whereas in always, if you call stop on this, it will fire up another one to replace it. And then we have a single environment variable in our environment block. This time the MySQL root password, which I've set to change me for the purposes of this. Otherwise, you end up with a random MySQL password, or the server reboots forever, complaining you have no root password, depending on exactly which version you have. We'll cover more on environment variables later on. So that's container number one. let's have container number 2. So we're going to fire up phpMyAdmin. So let's make another instance inside our Docker Compose. This is the same level as DB because it's the container name we're setting. We're saying make a new container of name phpMyAdmin. Unsurprisingly, the image we're going to be using is phpMyAdmin. We also want it to restart forever, so let's put restart always in there. However, because we want to actually interface with this externally, we're also going to have to punch some holes here. So let's open a port. So we have a ports stanza there, and this being YAML, lists start with hyphens, and because you can have a list of ports, we go in one level within ports, we have a hyphen, and then we have our port spec. Here we go to map port 8080, that's 8080, to port 8080. We could throw /TCP at the end of that if we wanted, but it doesn't actually matter for this demo. And you'll note that there I haven't given it a host to actually bind to. It should bind to any interface in this case. I'm doing this simply, even though it's bad practice, to show you can. Docker Compose will quite happily allow you to do this. We have an environment variable called PMA arbitrary with an underscore. This is a requirement of phpAdmin that makes it go to an arbitrary address rather than it trying to find the server itself, because we're going to tell it where it is in a moment. And we also have the I didn't realize I very poor grammar there at the bottom. Sorry about that. And we also have this depends on stanza right at the end of this container specification. And depends on essentially tells the container that it should try and wait until all the things it depends on have finished starting up. The mechanism for telling whether something is started up is complex, and we can go into it if someone has any particular trouble with that. But in general, you probably want phpMyAdmin to only start if it has a database to connect to. Otherwise, it's a bit pointless. So we've joined together these two containers so that we wait for one on the other. As a reminder again, the cat's telling you this is a list. So each one of these should start with a hyphen character. So hyphen space, the container. And then if you wanted another one, you could have a new line, hyphen space, the other container you're dependent on. So if we save that file, pop into the same directory as it in your terminal, and run docker-compose up. And you should hopefully see something a bit like that. Boom. So, yeah, that's a lot of layers. phpMyAdmin's container is, the container image is quite complex. It's got a whole bunch of stuff for dealing with different web configurations in there, and so it's quite deep. I think it inherits from quite a deep set of previous images as well. Remember, of course, we said last time that one image can have the contents of another. They were a big chain going back to the null image, which had nothing in it. Yeah, you'll see it'll download, and eventually they will say they've completed and that things are running.
So hang on, mate. I'm doing docker-compose space up.
Yes.
No configuration file provided.
Are you in the same directory as your docker underscore compose? So I think I may have.
Is it underscore or?
Have I typoed it on every single slide? It's an underscore, but apologies, I've used a hyphen. I do that. I will change that on the slides I share out. That should be docker_compose.yml.
Yes, so please could you flick back a couple of slides just so I can see the.
You want the?
So it's docker
typer, sorry.
docker_compose
.yml. Yeah.
Not dash initial.
No. My apologies on that one.
No.
All lowercase, all everything.
Yeah.
You're worrying me now, Paul.
Sorry.
What have you done? How have you broken things?
I've saved the file, docker_compose.yaml, doing docker compose.
Which Docker Compose do you have installed?
Oh, I don't know.
Interesting. Broken
I
it
mean,
though.
this is on a Mac, so
Yeah, well, I'm on a Mac.
Well done, Paul.
Yeah.
yay! Do I get a badge?
No.
Can't fix it.
With Docker Compose, I believe the -f flag lets you specify a different file name.
Yeah, I was just checking that.
And this is presumably installed along with Docker Desktop last week.
Yeah, it should all be just there. That's somewhat concerning. Huh.
We can solve it later. I'll just watch along.
That's very broken. I don't know what you've done there. Is anyone else having any trouble with this?
I'm not there even.
I'm just
That's
doing our
very peculiar. Yeah, sorry, that's very, very peculiar. If we hop out of this for a moment, hello folks, and I will just get the other one, this one up. Here we go. Share this. Not now. Grab a window. Windows. Here we go.
Docker Compose is telling me that actually it needs to be Docker-compose.1.
Oh, it is Docker-Docker.
Yeah, no, I did that.
Interesting. You've managed to break my demo. I'm impressed.
Oz.
Because it should do that. Hopefully it's being shared on Teams. And then it should run.
All right.
So, yeah.
Just me.
Yeah. Can somebody else confirm that it is working before we go on? Because I don't want to just move on blindly. I'll resume sharing my screen with the presentation for now.
It's just not finding the file somehow, but I may have made many.
You're not mounted on some weird file system, are you?
Not for that, no.
No. Okay. Give folks a moment with that up.
Yeah, I mean, I may have mistyped things in the Docker Compose file.
And it should tell you if it can't understand your compose file. It shouldn't just drop out. It's saying it can't find it, which makes me wonder about your shell. Are we getting any joy? Building?
Getting there.
Yeah, building. It's you, Paul. Yeah. Great. So Paul's broken. That's perfect. Oh. Cool. So you should see it downloading a bunch of stuff. Once it's completed doing that, you'll get to a state where it just sort of stops scrolling. You should be able to go to localhost at port 8080, and it should give you the phpMyAdmin login page. It might take you a moment to download everything and build those containers. The default details for the server is DB, the username is root, those are all lowercase, and the password is change_me, where the me is capitalized. I don't know. Come in here, ruining my presentations. Yeah. Right. So
I found a problem.
Go
on. In the Docker Compose file where you put MySQL root password, it needs to be MariaDB root password.
No, it doesn't.
Oh, well, it keeps giving me errors. It keeps saying it exited code 1 because it needs to be MariaDB root password.
Interesting. Because it doesn't on here. Because I'm literally just pasting that in. Okay, cool. Right. Well, okay. Change it to MySQL. It should basically be the same. MariaDB is a white room re-implementation of the SQL protocol, so it should accept all the same args both ways. So whichever your system has picked, go for one of those. This is where you should end up going back to hub.docker.com and seeing what the various environment variables are for that particular container. But there we go. Hopefully that should bring that up. We've actually got that running. working, folks. Okay. Fingers crossed.
The cursor's blinking.
It should just stop scrolling, and then you can open a web browser and go. In any case.
Same error, even after changing it.
Let me just go back to what we had up here. Just throw some quotes around change me, would you? I don't think it's that, but it might just be that it's being very picky. But I mean, my compose file is literally what's on screen. And it fires up just fine. This is the problem with working on a bunch of different systems, everyone. This is, yeah. Things do updates and changes when you're not looking, between when you've written your slides and when you demo things. And then Paul comes in here and breaks it further.
A non-standard machine.
Yeah.
Me.
Oh dear, oh dear. Shall I carry on while we see if that works?
No,
or not? Right. So we've already talked about dependencies and bringing container up, and we've watched it. So hopefully eventually you will get your PHP MyAdmin login screen on port 8080. If you, once these are running, open a new terminal and run docker ps like we had in our previous session, you should now see that we've got two containers that have started up. I've got these in a folder called part 2, so it's named them part 2 hyphen the thing we called them -1, because if I ran docker compose up again in the same folder, we'd end up with a -2, and so on and so forth. You can also see on there that port 8080 on the wildcard address has been mapped through to port 80 for the PHP MyAdmin 1. And we have one unmapped port, 3306, from MariaDB, which isn't mapped to anything, which is exactly what we want. We can override the naming scheme for this, but most of the time you just don't care with it. They will come up with sensible names and they'll just deal with the routing for you. Once we actually get in there, we should have 2 running containers. We can connect into it, hopefully, and log in. And you should see something like the PHP MyAdmin screen on screen now. Don't worry if this page is too small. It's literally just a screenshot of the admin pages. But it would be nicer to have this a little bit more streamlined. And it would be nice to have this know which things to connect to automatically, and we should not let it be connected to from the external world. So let's put together a few more extra bits in here to join up and close off some options. So let's have a look at environment variables. And environment variables are a simple way of passing parameters into containers and into Docker Compose, or indeed both. We can pass any command on Linux an environment variable by prefixing the command with a space-delimited list of parameters and values. So this is what I'm showing on screen here with variable _key equals, end quotes, some value, space, then the command I actually want to run. And that will just keep that in the environment for that one command. You can have several of these, so you can just have more than one with spaces between them. And you can export them to your current running shell or your current running context with export and then the same syntax without the command, in this case, because we're just talking about the environment variable. And they will then be persistent for that shell session, so you won't have to keep putting them before every command. Do be careful when you do that, because you can trash environment variables that the system actually wants to use. So it's worth having these being fairly uniquely named. If you ever want to see what your system is running, and this is Linux specific, if you run just export with no command, no additional parameters, it will just dump the entire environment to your screen. When we pass, oh, Paul's put his hands in the air. Have you got it working?
Yep.
What was it?
Just put a space between Docker and Compose instead of a hyphen.
That's not the command, but cool.
Well,
What have you installed? You sort of like weird black market Docker
Oh, yeah.
components that you
Yeah,
can't for. Yeah.
dodgywebsite.com.
Oh dear. So, Docker Compose. We can pass these to Docker Compose, and we can pass on then the values to the containers that we ask it to run. To do this, we use the $bracket syntax. That's curly braces there. And we can just drop this in anywhere we would expect a string to be in our YAML file. And as YAML files are entirely strings, you can put them pretty much anywhere. So if you were to put $curly brace the underscore variable, curly brace, and then pass in an environment variable called the underscore variable with some value, it will be replaced in our file with whatever our value was. It does have some handy extras as of Docker Compose 2.1. So you can have default values, and the syntax that is colon and negative, that's colon hyphen the default. So in that case, it would be if you have no variable, so if it's unset, or if the variable is totally empty, replace it with the default. And there's a variation of this where it's just hyphen default, and that just becomes default if the variable is just unset. So a blank variable is also replaced. So you have to be a little bit careful if you can have a valid condition where an environment variable is empty, but you want it to be sunset. You can also have some error strings on this as well. So if you absolutely need to have something set for something to run, you can throw in this question mark. So you have your variable name, question mark, then a string that will be your error message. And it will just bomb out with, can't do it, I need this environment variable on the terminal when you do this. In fact, we can actually extend what we're about to see with this so that we have that error state. So if we go back to our Docker Compose, we can replace our MySQL root password with the environment variable. I'm just going to call it pass. You can call it anything you like. Just make sure it isn't another one that's already existent on your system before you do this. Now, because we've changed it on the MySQL root password for the database, note that I've changed my database from DB to database here as well, just for clarity. We also need to tell phpMyAdmin that it's the same thing. So in our environment block for phpMyAdmin, we can also include PMA underscore password, also $bracket pass bracket. So whatever we set pass to, it'll show up in both. The advantage in doing this is that now if you were to save this file on a GitHub page or distribute it to other people, you're not giving away your secret database password. You have to give it to it when you launch it. A lot of container orchestrators will also, I think all of them, will also allow you to set environment variables for launching containers, which you can then pick up with Compose or Docker itself to replace in these files. We've also patched in that loopback check for our ports. So instead of listening on the all interface, we're now listening on 127.0.1. This probably won't make a visible difference to when you're running on your own machines, but it'll stop anyone else from connecting to your machine now as well. Again, good practice. Try and be secure by default. And this is also where you would start to kick in with reverse proxies if you wanted to actually have a remote access for this. And then we've added a few other bits with the environment, so not just the password for phpMyAdmin. We've also told it the PMA host, which is database, and we're using the name of the container, which, as we said before, was becoming the host name, effectively, of the running instance. And we've also told it the username and PMA user, which is just root, which is the default one. So now, phpMyAdmin should know all the things it needs to log in. So when we run it next, I'll leave it on this screen for the moment. So when we run it next, two things will happen. One, we'll have to specify pass on our environment, and we should now not have to log into phpMyAdmin. It should just take us straight through. I'm just giving people a moment to write any of that. People in the room, are you both up to speed?
Mine is still doing the first Docker Compose, so I'm just wondering what to do, because I've now edited the Docker Compose while it's reading it.
That's fine.
Maybe.
You can Control-C inside the running one and then just start it again if you wanted to.
Okay.
Exit out and then just rerun it. Run Docker Compose down as well, just to remove any of the old stuff, just in case you've got some weird hanging state. But yeah, are you okay with?
No, I'll just crash my command line. That's fine. Carry on.
Perfect.
Carry on without me.
As I said, all these slides in the recording will be available afterwards. So yeah, I know Mo's not even following along. He's not even trying. So
Sorry.
yeah. So if we've got all these working and we hit go, we'll need to give it pass, as I said, and we do this by doing pass equals quote the thing we want our password to be, end quote, and then docker compose up, or if you're Paul, docker space compose up, apparently. If we want this to run in the background so that we can do other things in the terminal, we can tack a -D on the end of that and it'll put it into daemon mode. So it'll run without keeping the terminal open with all the logs in there. But we probably don't want to do that to start with, so we can see what it does. It should be essentially indistinguishable from the previous run because all we've done is change some parameters and hit go. But now if you go to localhost port 8080, it should just sign you straight in. There should be no login screen whatsoever. Now you can see why you might want to bind that to only your host machine at that point, because you have no credential block before you have someone accessing your database. If we wanted to bring down that running instance for Docker Compose, especially if we've done -D, where we no longer have it running in foreground, so we can't just press Control-C to get rid of it, we can run Docker Compose down. This will stop any of the containers. It will then bring containers down. So this is effectively the docker rn command we were using before. And then it will shut down and remove any volumes. You and indeed the cat are probably confused by the term volumes, and we're about to go into that. So files and disks and IO, oh my. So far we've only dealt with networking and just running things in containers. But this is the section where NLP folks, as you all are, will sit up and go, oh, I can put my corpus in here. So, previously we said not to copy large amounts of data into a container because the images get huge and then they're unwieldy and a pain to deal with. So rather than copying into the image, we can instead mount a location elsewhere into a running system. So we can connect to remote stores as well, like MinIO and Friends and AWS and other external web things, as long as we have a valid network link. But that's exactly the same as connecting from the host. So we're not going to cover it here because you would have to do exactly the same steps with whatever library you have for whatever runtime you need. So bind mounting is the way we can do a lot of this stuff. Docker mounts parts of the host file system as an overlay inside the container. Those of you familiar with symbolic links in Linux, where you can symlink from one point in your file tree to another point, and it pretends to be there, effectively, will find this very familiar. We do have a little more control than just a regular symlink, however, because we can also set read and write modes for that mount. So we can have a read-only mode, which may be very useful if you don't want to accidentally edit your corpus. You can also have slightly magic ones that do things where it's got a read-only mount and then a change file, so it only writes the changes to a separate place, so you don't mangle your original one. But we're not going to do that. That's kind of an advanced thing. If you want to know how to do that, then come and find me afterwards. But in our demo, we would like to keep the actual database data in a folder that lives on the host, rather than just being destroyed in our container whenever we tear this down. So let's add that to our Docker Compose file. Our database needs to be added to a volumes section. So if we go back up to our database service descriptor and give it a new sublevel called volumes, and volumes is a list, so we use the hyphen for it. We can specify one or more volumes to mount here. Like I say, we're only dealing with bind at the moment. We'll talk about actual internal Docker volumes in a moment. But the format for this is the local path, colon, the container path, colon, the permissions. And the colon permissions bit is actually optional. If you don't have it there, it'll mount it just fine. Let's mount it read-write because we explicitly want to be able to write to our own database store here, otherwise it won't do very much at all. And let's mount a folder called data, and I've done /data here to say that I want to do it from the running, from the program running directory, the working directory of where we run Docker Compose, as a relative file. You could also do this as an absolute file. In fact, I do that on web services a lot, so that I can't accidentally bounce something somewhere strange. But the container path should always be absolute. So it should always start with a / from root and go the full tree, just so you know exactly what's going on. As I said, permissions can either be read-only or read-write for this. This is the short form of the mounting standard. There is a long form that has even more options. And I highly recommend looking at the volumes page on the Docker Compose reference for this, because they will explain it far better than I can. There's a whole load of different ways of mounting stuff, but bind mounts are by and far the most common one I use for development, because it's running on my machine. I want to be able to connect stuff that's on my machine. When you start to go onto an orchestrated larger network where you have multiple hosts, then you'd have to talk to the host to see how they want you to mount volumes there. I'm not going to go through this now. I've linked it on the slide deck and it'll be available afterwards. As I mentioned, Docker also has the concept of a volume, which is managed by Docker itself. This is a bit like a VMDK, a virtual machine disk image, VMDI. Yeah, VMDI, for something like VirtualBox, where it's a disk that lives within the runtime somewhere else. It's held by Docker, and that you mount in from within Docker itself, but is essentially just a file somewhere, so you can move it around independently, and it has some benefits. These can be shared between containers, which you can't really do with bind mounts. It would like to have one per container if it's going to do anything. They have their own quirks, and most NLP tasks are probably going to be wanting to map very big local things or very big networked things. So I'm going to skip that for this audience, but I'll quite happily go over volumes at a later date if people are interested. And the cat is very, very happy that we're not doing that, because that's a whole other kettle of fish.
10 minutes.
Nowhere. So let's go back to our folder, the Docker Compose file. Let's make a folder called data. Make drd data if you're on Linux, or I think it's the same on Windows as well. Memory serves. Remember to set your pass variable if you've used the the environment variable thing, and so pass quote some other string, doesn't matter what it is. In quotes, docker hyphen or space compose up -d, and you should see that it spins up, and it will start doing things. It will start writing and creating its database and doing all the rest of it. Now, we can run docker ps to make sure that it's up and running. You see here, I've run Docker Compose up with background mode. I've checked with docker ps to see that it's running, and I can see them both up and running. And if I run ls data, or if you go dir data and then dir within directory on Windows, you'll see that it has the files for the database. So now our files for our database, or the state, is kept separate from our container. So we've allowed it to write out into the host. Now, even if we start and stop the container at this point, these will persist. So we can quite happily type docker hyphen space down, and this will tear down those containers. You can confirm that with docker ps and make sure they're gone, or docker ps -a, remembering that will then show you removed ones as well. And the data will still be there. You can look into that and it'll still be perfectly fine. It's as safe as any other data on your machine. And that's kind of where we're going to stop for all of this, because we've now got access to stuff on your machine, and we've looked at more about how to connect to the network and how to launch multiple containers together. So that should give you enough to kind of be really quite dangerous with Docker at this point. I really should have renamed this Being Dangerous with Docker. But how can we take this further? If you want to look at the images we use today, they're on Docker Hub. They have excellent documentation, and they have links to their GitHub pages, which has even further excellent documentation. Those links are there. That's MariaDB and PHP-MyAdmin. They're just ones I picked because they're a nice set to try. Both of these also have a lightweight equivalent, so you could have a -Alpine build for this. And I challenge you to go away and make a smaller build of all of this, by changing your images to be the Alpine versions and building that locally. And you can also go to Docker Hub itself, so hub.docker.com. So a global repository of images, and generally look for the highly rated ones, and ideally ones with an official marker on them to say that they are the ones that you should be using. And there's software out there that you can go and try. Docker Compose reference is excellent. I highly recommend reading through that if you're confused by any of this. It goes through step by step and a lot of it. They have guides for all of the different features of Docker Compose. Can't recommend it more. Like I said, it's better than the documentation that I write, which honestly isn't saying much. And finally, and this is more a note for people specifically at SCC rather than for on the recording, as I said, SCC is moving more towards using Docker for smaller tasks within our VM cluster. So moving away from full fat VMs for literally everything. Easier to manage fewer hosts with a lot of small containers rather than lots of big VMs we all have to maintain for security issues. And there's an ongoing concern with lots of out-of-date VMs kicking around and remote access therein. Container templates are in the pipeline for common configuration. So if you just want our website here and today, we're hoping we have something ready to do that. So we can just hand things out and go, here you go, run this, and it'll give you a website. And it'll be integrated with GitLab if we can possibly manage it. So you can just copy a repo, put your file, anything you want on the web, hit go, it'll build it and deploy it all in one go. And it should cut out a lot of the administration overhead that we have at the moment with either running, setting up, or maintaining any of the VMs. And that is that. Cat's got coffee again, as do I. Thank you very much for your time and attention. And any questions?
Shall I stop the recording?